So normally, in order to find the remainder of a polynomial divided by another polynomial, you would divide them and then you would get the remainder. And you would divide them by either doing long division or synthetic division. And we have videos on how to do those, so if you don't know how to do those, then I would suggest go watching the videos. And in this video, we're going to be doing long division, so no synthetic division. So first, let's divide x cubed plus 5x squared minus 11x plus 3 by x minus 2. So x squared at the top, x cubed minus 2x squared is 7x minus 11x plus 7x, well, actually 7x squared. 7x squared minus 14x, you get 3x plus 3 plus 3 at the top, and 3x minus 6, so the remainder is 9. And that was pretty easy. We just do long division and we wait until we get a single number at the end, and we got 9. But there's an easier way to find the remainder. So in order to find out the remainder, we can look at this divisor and set it equal to 0. So x minus 2, if we set it equal to 0, then x is equal to 2. Or we can just take like the last number, in this case is 2. If the sign is subtraction, if it's addition, we just take the negative of it. So we take 2 and we replace it for x inside the dividend. So we get 2 cubed plus 5 times 2 squared minus 11 times 2 plus 3. And we get 8 plus 5 times 4, which is 20, minus 22 plus 3. And this, we get 9. And notice how they're the same number, so we can use this to find the remainder even easier just by plugging in. As we said, set the divisor equal to 0 and find x, and then plug in x back into the original dividend and you'll find the remainder. And for this, k minus 2 is a factor of x cubed minus 2x squared minus 3x plus 6. You can check it yourself doing long division or synthetic division, but x minus 2 is a factor. And if we apply the remainder theorem, you might think it won't work or something because the remainder should be 0. But if we set x to 2 and plug it back into here, 2 cubed minus 2 times 2 squared minus 3 times 2 plus 6, we get 8 minus 2 times 4, which is 8, minus 6 plus 6. And notice that this equals 0, which makes sense because the remainder should be 0. And this works for all polynomials divided by something that's a factor of it. If you use the remainder theorem, the output is going to be 0. And this is called the factor theorem. Whenever the remainder is 0 or something is a factor, when you apply the remainder theorem to it, then the output will always be 0. Now let's get into some examples. So if we want to find the remainder of this, x cubed plus 2x squared minus 7x plus 5 divided by x minus 1. We don't need to do long division or synthetic division, as we said. We can just use the remainder theorem. So x minus 1, we set this equal to 0, and we get x is equal to 1 pretty easy. And we replace 1 inside the dividend, and we get 1 cubed plus 2 times 1 squared minus 7 times 1 plus 5. And this is just 1 plus 2 minus 7 plus 5. And 3 minus 7, negative 4 plus 5, this is equal to 1. So this means that the remainder of this is just 1 using the remainder theorem. And if we have something like this, where we're given a polynomial but one thing is missing, which is k right here, and we're given one of the factors, here is x plus 2 is a factor, we can use the factor theorem to find the missing number. So x plus 2, we set this equal to 0, and we get x minus x equals negative 2. And let's plug that in to the original polynomial. So 2 times negative 2 cubed plus negative 2 squared plus k times negative 2 minus 4. And since it's a factor, it's going to equal to 0 because of the factor theorem. And then this is going to be negative 16 plus 4 minus 2k minus 4 equals 0. And then we get negative 2k is equal to 16. So k equals negative 8. And now we just found out the missing number pretty easily just using the factor theorem by setting the factor equal to 0 and finding what x equals, and then plugging that back into the original equation, and then just using some simple algebra to figure it out like we did here. Now let's get into some practice problems. If you're thinking how to do this one, then pause the video and try it. But this one asks, when x cubed plus 2x squared plus ax plus b is divided by x minus 1, the remainder is 4. And when divided by x plus 2, the remainder is 16. Find a and b. So what makes this problem tricky is that we have two missing variables inside the original polynomial, but we could just use the remainder theorem to make it a system of equations. So when divided by x minus 1, the remainder is 4. So let's set x equal to 1, because if we set x minus 1 equal to 0, then x equals 1, and plug it back into the original polynomial. So 1 cubed plus 2 times 1 squared plus a plus b is equal to 4, which is the remainder. And we get a plus b equals 1 just by using algebra. So we have our first equation relating a and b. And now let's do the other one. X plus 2 equals to 0, and we get x equals negative 2. So let's plug negative 2 back into this equation. So negative 2 cubed plus 2 times negative 2 squared plus a times negative 2 plus b, and we get negative 8 plus 8 minus 2a plus b, and we set this equal to 16, which is the remainder, and we get negative 2a plus b is equal to 16. So now we have both of our equations, and let's set a by itself in the first one. So a equals 1 minus b, pretty simple. And then we plug it back into the other one, so negative 2 times 1 minus b plus b equals 16, and negative 2 plus 2b plus b equals 16, and we get negative 2 plus 3b equals 16, and then bring it over here, we get 3b equals 18, and b equals 6. So now we have our first number solved, b, and the rest is pretty simple. Just plugging b back into here. A equals 1 minus 6, which is what b equals, and we get a equals negative 5. And now we just figured out both of the variables just by using the remainder theorem, and then simplifying it down to system of equations. Now let's do another practice problem. If you're thinking how to do this one, then pause the video and try it. But this one asks, find a and b if 2x cubed plus ax squared plus bx plus 5 has factors x minus 1 and x plus 5. So we learned earlier in this video that if a polynomial has a factor like x minus 1 or x plus 5, then that means if you use the remainder theorem for that, then the output will always be 0 because the remainder is 0. So let's plug in both 1 and negative 5 into the equation because that's what x equals if we set both of these to 0. So first let's do 2 times 1 cubed plus a1 squared plus b times 1 plus 5 equals 0. And we get 2 plus a plus b plus 5 equals 0. So a plus b equals negative 7. And you can already tell that this problem is going to be similar to the last problem where it's just a system of equations and you have to use some algebra to figure it out. But let's just start with the second one, x equals -5, because x plus 5 is a factor. So 2 times -5 cubed plus a times -5 squared plus b times -5 plus 5. And now -5 squared is -125 times 2 is -250 plus 25a minus 5b plus 5. And this simplifies to -245 plus 25a minus 5b equals 0. And then let's put the 245 on the other side. So 25a minus 5b equals 245. And if we divide the whole thing by 5, we get 5a minus b is equal to 49. So now we have two equations. A plus b equals -7 and 5a minus b equals 49. So let's do the same thing we did last time. Set a by itself. A equals -7 minus b, and plug it back into the other equation. So 5 times -7 minus b equals 49, and we get -35 minus 5b minus b equals 49, and 49 plus 35 is equal to 84. So 6b or -6b equals 84, and we get b equals -14. So we found one of our numbers, but what's a? All we have to do is plug in b into this equation. So a is equal to -7 minus -14, and we get equal to -7 plus 14, which is just a equals 7. So we found both of our variables, a equals 7 and b equals -14, just by using the same logic as we did on the last problem, just using the factor theorem instead of the remainder theorem. So everything that I explained in this video and all the problems that I went through should teach you everything that I need to know about the factor theorem and the remainder theorem and how to use them. If you learned something from this video, then please consider liking or subscribing.